correlating rock layers. Okay, so correlating rock layers involves matching rock layers that were formed at the same time. So this is taking a rock layer in one location, another location, matching them up that these layers formed at the same time. And how we're going to do that, we're going to use things like index fossils and volcanic ash layers. That's going to be like our tools to do it. So here's an example. So this is a fossil of a trilobite. It's a Leptocephalia. And we first see this species come about 530 million years ago. That's what that means. And it went extinct about 520 million years ago, so it only lived for that 10 million year time frame, which is a short time frame. I know it's crazy to say 10 million years is a short time frame, but in geology, that is a short time frame. So therefore, because it came about here and went extinct here, any rock that has a fossil of Elliptocephalia in it must have formed during that 10 million year time period. So that's going to help us correlate these rock layers. Now, here is the centerfold of the reference table, page 8. We're gonna look right down here, and these are species of trilobites. So this is one we're looking at. This is all trilobites and how they changed over the years as they evolved. But this is what we're looking for, and its reference is letter A on the reference table. So let's go here. Where do I see that? I see that right here. Okay, now we're going to zoom in. And so this is A, and it gives you these, this is that time frame which we're talking about, that approximately 530 to 520 million years ago. So that is often something that you need to do, use the reference table to determine the age of certain fossils. So this is sort of the problem where we have three different locations here and outcrops of rocks, and we're trying to match up what layers sort of formed at the same time. And we're going to use fossils to do it, and we're going to use the fossils of this Elliptocephalia to help us. So we can see it in these locations here. Okay, so that helps. You want them to be in all the rock layers to match them up. If they're not in one of them, it doesn't really help you. Therefore, these rock layers highlighted in yellow, they all formed pretty much at the same time, which is, you know, the rocks here are all of that time frame is when they formed. Okay. So that's one way to sort of match them up and give us a time frame if we use the reference table. Another way is using volcanic ash layers. So here we have three outcrops again, and they have volcanic ash layer labeled in black here. Okay, and we also can use this to match up rock layers, because volcanic ash layers help us correlate rock layers, because ash from a huge eruption is deposited all over Earth at the same time. I'm talking of a volcanic eruption that you have never seen in your lifetime, and I've never seen in my lifetime, that is just tremendously huge, puts ash throughout the whole atmosphere, and that ash will go all around the Earth and slowly settle down and then be deposited in oceans and lakes, and all pretty much at the same time. So we can match them up to have formed tell us the time that they formed. They formed at the same time. And a question you may get is something like this. Volcanic ash is a good geologic time marker because the ash is deposited rapidly over a large area. So it is deposited rapidly over maybe a few years, you know, anywhere, you know, in about a 10-year time period, which in geology is really short. So we could use them to match those layers time-wise. Here's another question, that's a similar thing. Volcanic ash layer is a good geologic time marker for correlating rock layers because the ash layer was deposited over a wide geographic area over a short time period. Okay, it gives you a sense of some of the things that we use volcanic ash for. Now this one here, we're back to fossils. Which rock layer is the youngest? Okay, so this is unique. You have to sort of use the visual fossils. You have to match them up visually using the reference table. You will not be able to answer those without the reference table. I've seen students try to do it. They're just guessing at that point. You're guessing. So you need the reference table. And you need to go down here, the pictures of the fossils, the diagrams, to match them up. And I kind of did this a bit here. I cut them out. So these are the fossils, and this is the reference letters, D, R, W, and Y. So what let's zoom into this area here. So this is where those letters sort of tell us this timeline of when they existed. So we're zoomed in. Now, fossil D, see how I matched them up with the colors here? So with this is older and towards the top is more recent. So therefore, the most recent index fossil here is going to be fossil R, okay, which is a placoderm fish, which is this right here. So this is all things that you need to do. And then go back here and say, well, which one must be the youngest, most recent? Well, it's this right here, but it doesn't say placoderm fish. It does say outcrop 1. You probably could answer it just on that. Yeah, I cut off outcrop 4 actually, but what I was referring to, it says you would see the symbol for sandstone is this, because that's the kind of rock that it's in. So it is in sandstone. You would know that by looking at page 7 of the reference table here, and therefore you can go back and realize that the answer here, the youngest one, is the sandstone in outcrop 1. Okay, that's another one you had to work hard for. There's a lot of back and forth, so really know your tools, being the reference table here, and how to go back and forth. Some of them are easier than others. This is one of the more challenging ones, but hopefully you get the gist of it.